the foremost scientist who's done work on coal fly ash as a construction material is a British scientist, Lyndon Sear, and his book, published within the last 6 months, concludes the end of the book. The problems of full-scale production of bricks and Panamania fly ash remain to be worked out, which is his British understated way of saying it doesn't work yet. Just like nuclear fusion, it's a very good idea, but it's not commercially practical today. So the second problem that Ed McCullough was asked to work on, if you want to explore Mars by something other than a little basketball-sized rover that takes 30 yards a day, and you've got something the size of Australia or something the size of Africa that you want to go through, it's going to be a very, very, very long process to explore Mars. If you'd like to get up in the air and take aerial photographs and go zip around and see what the coastlines of former seas look like, but you have this problem. Mars jets can't burn because the Martian atmosphere is about 1.4, 1.5% oxygen. So Ed was asked for his next boy genius wonder thing to develop a way to get a Mars jet to work. Ed turned to over 80 different combinations. The one that he hit upon was a thing involving a series of magnesium compounds. Magnesium burns really hot. It burns so hot that when you ignite it underwater, it will still continue to burn. It burns at about 2,000 degrees. It makes it possible to weld or repair submarines underwater. It makes it possible to repair ship hulls, to do underwater tier repair. It's a really hot burning thing. When you get it burning, magnesium is so highly cationic, it reaches into a carbon dioxide atom, grabs the carbon out, and in that process frees up the two oxygen molecules. Now you have the oxygen necessary to burn for a Mars jet. So imagine taking the Martian atmosphere, mostly, that is to say 80% carbon dioxide, running it through a grid embedded with magnesium, where you've got the magnesium burning. The carbon dioxide has the carbon stripped out, and it's not just separated and put into a different gas plume. It becomes a powder that falls down. It becomes carbon black. Carbon black turns out to be the way we get our naturally gray-colored rubber in rubber tires to look black. It turns out to be the way we all print on computer printout. It turns out to be, among other things, one of the clever ways for us to get carbon nanotubes. The carbon produced from a really high temperature burn, like a magnesium burn, is about 1/3 carbon nanotubes. Carbon nanotubes research today, some of the hottest research going on the planet, it's hampered by the fact that 1 pound of carbon nanotube material costs you $1,400. Ed McCullough's technique appears to be able to reduce that cost to 1/6 of its present production cost. So if you had the opportunity to look at this slide again, what a disaster, or that's $1 billion laying there in the ground. If you could take that coal fly ash, it was contained in a nice place. If you could take it and refine it, there's $1 billion worth of materials there. Think of $1 billion worth of pennies. Now the study that I'm referring to was done by Boeing under Ed's direction in 1995. The $1 billion valuation is now 14 years old. In the interim 14 years, we've had a phenomenon arise called the modern state of China. In 10 of those 14 years, China has built 116 cities of 1 million people or more. To put that in perspective, Pittsburgh has 650,000 people. So think of us setting out to build 116 Pittsburghs. The amount of aluminum, the amount of copper, the amount of silica, the amount of any material that you need to build the skyscrapers, the homes, the railways, the bridges, it's going to require our material science to figure out new ways to get aluminum, new ways to get silica, new ways to get titanium, magnesium, molybdenum, all the things that we saw in the earlier slide of what lunar regolith is made of. The opportunity here is for us to seize the future. This is not pie in the sky. This is not lunar scientists gone lunatic mad. This is a thing that can work today. Ed McCullough has demonstrated it. It is now ready for the check to be written to build the pilot plant now. We've got coal fly ash as a problem. We can turn it into a solution. We can use the magnesium, among other things, produced to strip out the carbon dioxide and produce something more valuable than a waste product that clogs our waterways, that leaches out heavy metals, that causes destructive coal fly ash brick problems in our voc rehab centers. It's a matter of political will. It's not a technical objection. It's time for us to seize the future. This is the way. Questions? I can see I've obviously talked too rapidly with no questions. Ed? Yes, Richard.
I always wanted to ask you, how old are the four patents?
They were produced in 1994-95. And one of the sidelines that I used to be when I was in Wall Street was intellectual property patent lawyer. So with the proper husbanding, you've got 34 years total, and you're approximately 14 years through that. So you've got 20 years to make this commercial hay. If there are no questions, I'd be happy to answer questions after the speeches are over, but if there are no questions, I would be also happy to stand in the corner back here and take checks from those of you who are interested in being part of the first coal fly ash refining enterprise. It's not my business, it's Ed McCullough's business, but I've agreed to help him find financing for the pilot plant. It's a $10 to $15 million pilot plant. The commercial production would be 300,000 tons a year. That's about a $100 million plant. And the economics of it are just plain as dirt stupid. It costs $200 a ton to refine, and it produces $517 a ton worth of material. Remember the $1 billion laying on the ground. You don't want to leave $1 billion worth of pennies laying around. You want to get busy. Thank you very much.
Good morning. My name is Julia McAfee, and it's my pleasure to introduce our next speaker, Mr. James K. Martin. Mr. Martin joined Dominion Energy in June of 2000. On April 1st of this year, Mr. Martin assumed his current position of Senior Vice President, Regulation and Integrated Planning. In this capacity, his responsibilities include oversight of state and federal regulatory strategies, filings, proceedings, as well as Dominion's conservation and load management initiatives and integrated resource planning. Mr. Martin, a Charleston, West Virginia native, came to Dominion from Peabody Coal Company, where he was Vice President of Sales and Marketing. While at Peabody, Mr. Martin was responsible for developing business opportunities and integrating coal with power, emissions, transportation, and other tradable commodities to meet the changing needs of the energy markets. Mr. Martin serves as chairman of the World Affairs Council of Richmond and is a member of the Virginia Coal and Energy Commission. He is past president of the North Carolina Coal Institute and the Southern Coals Conference. And now, to speak to us on new directions in energy, please join me in welcoming James K. Martin.
Thank you for that kind introduction. Don, I may need some help here.